Today we will be graphing a linear inequality. And we've graphed equations before, but now the difference is instead of an equal sign, we're going to have an inequality sign. And so the only difference is that we are going to have a certain line type, and we're also going to have to shade the possible solutions. So line type, it works this way. We use a solid line if the graph equals or is greater or less than. So if we have these symbols here, greater than or equal to or less than or equal to, we're going to end up using that solid line. We use a dash line if it does not equal. That represents that the line is not a solution. And so we're going to end up using the dash line if we have a greater than or a less than symbol. Now the shading. The shading represents where the solutions are. So the solutions are either going to be on one side of the line or the other. And the solutions mean that they work for a value works for the equation. And we'll give an example of that afterwards. So shading above. We always shade above when we have a positive y. Now this is only when we have a positive y, and positive y is greater than or greater than or equal to. So the values of y are bigger than. So that means you're going to end up shading above because y values have to be bigger than the rest of the equation. We shade below if it's a positive y again. Positive y is less than or equal to. So it's important to make sure you have a positive y. If we have the reverse, if it's a negative y, then that's when we'll end up having to switch the inequality sign around. So if you have a negative y, we need to divide by the -1 to make it a positive y. So we shade left or right only on these situations. If there is no y, there's no y term, and all we have is an x term. So if it's a positive x is less than or equal to, we're going to end up shading left because to the left is the smaller numbers. And again, only shade left or right if there's no y term. And we're going to end up shading either, right if it's a positive x is greater than, because the values of x that are bigger than or equal to are to the right. So let's take a look at some of the problems we have here. First thing to do is to just graph the line. Don't worry about drawing the line quite yet, just worry about graphing the line. So it's y is solved for. We've got y by itself. I'm going to start with +1. That's the y-intercept. And then I'm going to use the slope. Well, the slope is 2 to 1. So I'm going to just go up 2 over 1. Do that a few times so I have some points to make up that line. I could also go the other way. Remember, this is the same thing as -2 to positive, or to -1. And so that would mean down 2 to the left 1. And then you'd have some points as well. Well, from there, we can go ahead and draw the line. Now, before we draw the line, let's look at the type of line we have. So you see it is a greater than symbol. So greater means that it's just going to be a dashed line because we do not have that line underneath. So you're going to draw dashes where the line would. And what this line represents is the division between possible solutions and things that are not solutions. So we look at this y term. It's a positive y is greater. So greater means above. So we're going to end up shading on this side of the line. So the solutions are over on this side of the line, not below, because above gives us more or higher answers. And so what we can do is I can show you how it works by picking a point. So if we pick a point, like let's say we pick, let's go with -1, 1. So we pick this point here, -1, +1. If we plug those numbers in for x and y, it will work for the solution. So you see how it works? 1 goes in for y, and -1 for x. So it'd be 1 is greater than 2 times by -1 plus 1. So that makes y is greater than -2 plus 1, which makes -1. So if I go ahead and rewrite that, that'd be 1 is greater than -1, which is true. So what the solutions represent are true answers. Those values will end up working with this inequality. Numbers on the other side would not work with the inequality. So all we're concerned with is drawing the line, the correct type of line, either dashed or solid, and then which way the solutions are, either above the line or below the line. Above means like if you were climbing up the hill, like here you are climbing up the hill, well, above is above your head. So here's the person again, so you can see the person a little bit better. They're climbing up this hill, this mountain. Above is above their head. Below is below their feet. Well, we got another one here. Here we do not have y by itself. So in order to get y by itself, we're going to end up having to divide by a negative 1. Now that will do something here. So when you see that minus sign, divide by a negative, but divide all terms by a negative. And what we have left is the equation in slope-intercept form. We've got y is less than now. So it's not actually an equation, it's an inequality. The negative signs cancel, so we have x. 1 over negative 1 makes negative 1. So there's our y-intercept. So we're going down 1, and then we use the slope. The slope is 1 to 1. You're just going up 1 over 1 each time. And then that represents the line. You could also go the other way, down 1 to the left, and that gets us on the line as well. So we go ahead and draw those dashes between those points. And it's a dashed line again, not a solid line, because there's no line underneath. So no line means it's going to be a dashed line. And so that's what we're using. Now it's a positive y is greater, or is less than, less. So less means below. So we're going to end up shading below. And I know it's less because I read from the y to the inequality, and it points. So when I read the y, it points to me first, and so that's why I say less. If it was open to me, like here, it's open. As I read from the y to the inequality, I read y is greater than. But here I'm reading y is less than. And so this is the area that I would end up shading, just down in here. So these are the possible solutions, or everything that's down on this side. So if we picked a point up here, like let's say we picked 0, 0. See, this point is above that line. This point would not end up working. And we could see that by putting it in here. See, if we did 0 in for these numbers, we'd have 0 is less than negative 1. But 0 is not less than negative 1. It's greater. And so that's why the values up here are not solutions, only the values down below. And so our answer is the dashed line shaded below. Well, here's one where we don't have y by itself. So let's get y by itself. So what I'm going to do is do an opposite operation to isolate this variable. I'm going to subtract the x from both sides. So what I'm left with is a y is less than or equal to negative x plus 3. So positive 3, that's my y-intercept. So I go up 3, put the dot there, and then use the slope. This time the slope is negative 1 to 1. So that means down to the right. Put some dots there, and this time it's a little different. It's not a dashed line, it's a solid line. Why do you think it's a solid line? Well, it's that equal sign that's underneath the inequality. This means less than or equal to. So equal means a solid line. And so I'm going to draw that solid line through those points. And then from there, we can go ahead and figure out the shading. So we're either going to shade above, which is on this side. So this one would be above here. This is below. So we look at the inequality sign when y is by itself. It's a positive y is less than. So less means, right here, less means below. So think of less means we need smaller y values. The smaller y values are on this side. Bigger y values are above. They're on this side. So this is the region that we would end up shading. And it can be proven to you by just substituting a point in. Like if we pick this point right here, 0, 0, this is below the line. If I plug in 0 for these values, or 0 for these values, I'll get a true statement, because that's where we shaded. So 0 plus 0 is less than or equal to 3. See, that's true. 0 is less than or equal to 3. That makes sense. And that's why we shaded in this direction. If we picked a point above, that would not represent a true answer, and so that's why we did not shade there. Well, one more problem here. here we have to get the y by itself again. Now it's easier in this case to just go ahead and add y to both sides. See, it's a minus y. Let's add the y. There'll be one extra step though. So let's go ahead and rewrite what we've got. Now I've got 2x is less than or equal to 3 plus y. So now we have to move that 3 over to figure out what that y-intercept is. And here I'm going to subtract 3 from both sides. So I take that 3 away, and now I've got a 2x minus 3 is less than or equal to y. So y is greater than or equal to 2x minus 3. So I could rewrite this in that form if I wanted to. See, if I rewrote this up top here, I would rewrite that as y is greater than or equal to 2x minus 3. And you're probably more used to seeing it this way, because this is in that slope-intercept form with y on the left-hand side. But it means the same thing. You see how it's open towards the y here? Here it's open towards the y as well. So either way you do it, you'll get the same answer. Negative 3 is the y-intercept. Use the slope. The slope is 2 to 1. So it means you're going up 2 over 1 to the right each time. Or you could go down 2, 1 to the left. And then from there you draw the line. Now this is a solid line again. So always be really careful of the line type. Solid line because we have the line underneath. So that means equal to. Now this time it's a y is greater than. Greater, well, greater you think of as the bigger numbers. And they are bigger. You see y, the bigger numbers are up here for positive y. And if we went down here, these would be smaller. These are below the line because those y values are smaller. But we don't want the smaller. We want y to be bigger than. So that's why we end up shading in this region here. So that's an example of those problems we'll do. Part 2 will be some review on writing equations and solving systems.